Welcome back, everyone. This is the session 8 from the playlist of circular motion. The topic is the motion of a vehicle on a level circular road. The meaning of the level circular road is that there is no banking of the road. So, with regards to this topic, I have written down here two important points. The first point is that when a vehicle negotiates a circular path, it requires a centripetal force which should be directed towards the center of the circular path, because when a vehicle moves in a circular path, it experiences the centrifugal force which is directed radially outward. So, if the centripetal force is able to balance the centrifugal force, then in that case the vehicle will negotiate a circular path. So the point number 2 is, for maintaining a circular path, the static frictional force should be able to provide the necessary centripetal force, and it should be greater than or equal to the centrifugal force. Now the centrifugal force, as we all know, that is equal to mv square by r, where m is the mass of the vehicle in this case, v is the speed of the vehicle, and r is the radius of the circular path. So for maintaining this circular path, first of all, the static friction will provide the necessary centripetal force, and it should be greater than or equal to the centrifugal force. So the centrifugal force is equal to mv square by r, and the frictional force, that is the static friction or the static frictional force, this is equal to mu s into n, where n is a normal reaction, and the normal reaction is basically equal to m into g. So for maintaining a circular path, the static frictional force, first of all, it will be providing the necessary centripetal force, and at the same time it has to be greater than or equal to the centrifugal force. So we can say that mu s mg, it should be greater than equal to mv square by r. So this is the centrifugal force and this is the static frictional force. So this static frictional force has to be greater than or equal to the centrifugal force in order to maintain a circular path. And in order to obtain the maximum speed, this mv square by r should be equal to mu s mg. This mv square by r, it should be equal to mu s into mg. So from here, the maximum speed is equal to, the maximum speed, that is V max, this will be equal to under root of mu s r g. Now here mu s is the coefficient of the static friction, r is the radius of the circular path, g is the acceleration due to gravity, and m is the mass of the vehicle. And from this relation we can see that if the value of mu s, that is if the coefficient of static friction increases, then the maximum speed will increase. That is by keeping this radius of the circular path constant. If r is constant, then the maximum speed can increase if the coefficient of static friction increases. And if the coefficient of static friction is the same, then the maximum speed will increase if the radius of the circular path increases. So this is a very important relation with regards to finding the maximum speed of a vehicle which is moving in a circular path. So in the next session, I will be discussing about the motion of a vehicle on a banked road, that is when the road is tilted at a certain angle with the horizontal. So in that session, I will be discussing about the speed of the vehicle and we will be deriving the equation for the same, that is the speed of the vehicle when it is moving on a banking road. So till then, have a nice day. Bye.